Hey guys, did not expect to have to be doing distance learning today, so this is what I plan to go through in class, and you're going to do some classwork after this. Now this is what your notes should look like, so if you don't have a notebook out and your pencil, please go ahead and do that now. Just pause the video, get your notebooks out, because this needs to be in your notes, and I will be checking this next time we have class. So please have that in your notebooks. Okay, great. So here we're going to talk about the area of quadrilaterals, specifically today rectangles and parallelograms. There are actually 6 main distinct types of quadrilaterals. These are just 2 of them. For the sake of today, we can kind of group squares and rectangles together. For the sake of today, they are of course different. Squares have 4 equal sides and 4 right angles. Pardon me. Rectangles are their sister, brother, whatever, their sibling. Because rectangles don't have 4 equal sides, they have 2 pairs of equal parallel sides. What that means, you got 2 sets of lines. You got 2 lines that go side to side, which are the same length, and they are parallel, means they go the same direction. And you got 2 that also go up and down, again, same length, same direction. Hence why the ones going side to side have 1 little tick, and the ones going on the sides have 2 ticks to show they're the same. What makes a rectangle also rectangles, it has 4 right angles. This is where squares and rectangles are the same. They both have 4 right angles. It's also what sets parallelograms apart. So a parallelogram has 2 pairs of equal parallel sides, but it does not have 4 right angles. Instead, it has 2 pairs of equal angles. What I mean by that, if you notice in here, this angle is the same size as this angle. I'm just going to change colors. And this angle is the same size as that angle. And just like in the rectangle, this side should be the same as this side, and this one should be the same as that one. If they were all the same, means 4 equal sides that just are on a tilt, that's called a rhombus, and we'll talk about that in a couple days. But what this means is that, I'll type this for you, since parallelograms have these qualities, 2 pairs of equal parallel sides and 2 pairs of equal angles, and a rectangle has 2 pairs of equal parallel sides and 4 right angles, that still means there's 2 pairs of equal angle. They just have to all be the same. So all parallelograms are also rectangles, but not the other way around. Okay. Just like maybe you've heard that all squares are rectangles, but not all rectangles are squares. It's in the same category as that. We'll talk about that in a couple days. But the reason why we group these together, and squares that matter too, I just go ahead and just draw a square up here because they're in the same category. Got our squares that also kind of function the same way. They all function with this same idea of finding area. That area is base times height. It just matters kind of what that area, it kind of matters what that base and what that height are. Now in this rectangle on the left here, let's just go ahead and say that this side is 10 and this side is 7. You've been finding area forever. You've been doing, base times height or length times width. And so this area in here would be 70. Now let's say this was inches. This is also inches. This means that the area is in inches squared. Because it's area times area, therefore inches squared. On this parallelogram over here, let's go ahead and say that this side is 5 and this side is 6. That's actually not what we use. We do not, let me repeat that, we do not use this guy. This guy over here, we do not use that bit. This part we do not use for area. Okay? What we use instead is the height. And whenever you have a parallelogram, chances are you'll be told what the height is. You just got to know which number to use. So let's say that's 5, that's 6. This will never be a little bit shorter. Maybe it's 4, 4.5, something like that. It might even be 5. You would use that. You would use base times height. So that'd be 5 times 4, and you would get 20, whatever the unit is, squared. Okay. So again, you use the height. You do not use the diagonals. Those are called legs on a parallelogram. You would not use those to find the area. You would use base and height. Okay. So going over to your classwork to kind of check this out, I'm just going to show you how to do this today. So area rectangles. Area is the space inside of a two-dimensional figure. Use the formula capital A equals base height, touching base times height, where B is the length of the base and H is the height of the rectangle. Area can be measured in square units. So for example, in here, inches times inches would be inches squared, feet times feet would be feet squared, meters times meters would be meters squared, just like that. Okay? When you're working in here, and I'll just start number 1 for you, you've got a rectangle here that's 3 centimeters by 8.6 centimeters. In these formula lines, I do want you to write the formula, which is area equals base times height. Then you're going to plug in those values. You have area equals 3 times 8.6. I don't need to see your work in here. You can just solve it. If you want to use a calculator, go for it. Geometry uses calculators a lot. So you might as well just solve the area there and make sure your unit is in centimeters squared, because that was what we were talking about earlier, centimeters squared, whatever you get. You do the same thing for 2. Remember, when you're multiplying fractions, you're trying to do 2.5 times 1.5. You got to convert those to improper fractions. So 9/4 times 3/2, multiply across. Please don't forget. Okay. Number 3 is called word problem version. Same thing down here. You can kind of forget this bit. Really, I don't care. And then you'll just solve this out. Okay. Now this one says the area is 162. You got the height. You don't have the base. You'll use the same formula. Area equals base times height. Since you know the area now, you plug that in. You know the height, but you don't know the base. You can solve by doing inverse operations. Think back to algebra and how you would solve that. Okay. 5 and 6 run a similar way. Area parallelograms. Same deal. Use the formula again. Area equals base times height. All works the same way. Use the formula B. B is the length of the base and H is the height of the parallelogram, which makes a triangle with the base. We know, so that's kind of how that little guy works down there. So again, we use that formula. Area equals base times height. Again, here we are not going to use that 10. That is a leg, not a height. So you plug in your values. You know that the base here is 12.2 and the height is 8. Again, you'll solve. It'll be in centimeters squared. Now you might be wondering, hey, how do you know not to use the 10? Great question. How do I know that's a leg versus a base? Where the height is coming from, that is your base. Your height connects your bases like so. See how that dotted line goes from one base to the other base? That's how you know it's the height and not a leg. Okay. This want to see what you work out. Summarize today's lesson. You actually don't need to do this bit because it's kind of what you are doing here. Again, you'll just solve these, watch those fractions, watch those word problems. That should be about it. If you have any questions or concerns, please just reach out. Make sure you click turn in, wait for it to turn in. Don't be a chump and then be caught not having been turned in when you did the work. Okay. Be good, be safe, and hopefully I'll see you tomorrow.